chapter, and section 6.1 is about graphing inequalities. So basically, like I may have said in class, whether you were there or not, we've done a lot of stuff with equations over the semester so far, right? We've graphed equations, solved equations, worked with equations that just had an x, equations that just had an x and a y, systems of two equations at the same time, whatever. But now we're going to be looking at some inequalities, so what is this? Lock it. Anyway, now it's not going to be where like one side is equal to something else, where you would have an equal sign and it'd be called an equation. These are inequalities where the two sides of the statement are not necessarily just equal or equal at all. And so this symbol means not equal to, like not equal to. This symbol is the less than symbol, which you, no offense, you should already know this stuff. Like what these symbols are. Okay? And as you write these down, I mean, you really, by now, and it's not the end of the world if you don't. I mean, you can relearn these, or maybe you're just rusty or something. But if I had to explain, I mean, obviously, a lot of teachers look at these symbols as like the mouth of an alligator. And the alligator wants to eat the larger number. So the alligator mouth is going to be opening towards the larger number. So, if you had something like, might as well use purple, huh? 2 is less than 5. Because, and that's how you read it from left to right. The smaller number is less than something larger, So this symbol is the less than symbol because whatever is to the right is going to be bigger, and so whatever you're saying first is less than. Also, I don't really, this doesn't really naturally is what pops into my head, but I mean, the less than symbol looks more like an L than the greater than symbol, you know what I mean? I mean, you might disagree a little bit, but I don't think you can really argue that this one looks more like an L. You might not think it looks enough like an L, but it definitely looks more like an L than this one. But bottom line, for goodness sake, this is the less than symbol. This is like, you see how it's almost like a mix between a less than symbol and an equal sign. So less than or equal to. And for the same reason I just explained here, if you had like 5 is greater than 2, that's how you read it from left to right. And since the alligator wants to eat the larger number, that makes this a greater than symbol. Okay? Now, we're just going to start real simple, graphing these inequalities. Okay, so remember, graphs are like you're graphing the solution. So here, imagine all the numbers that you could plug in for x to make this a true statement. Could we plug in 1? Like, am I going to shade in? Am I going to graph the number 1 is 1 greater than 1? No, it isn't. It's not greater than 1. It's equal to 1. Is 2 greater than 1? Yeah. Is 0 greater than 1? Nope. 3. But what are we going to do? Because it's not just about the nice integers. Isn't, like, look. Isn't 1.5 bigger than 1? Like, isn't 1.5 something that could fill in for x and make this a true statement that makes sense? Yeah. Well, what about 1.1? What about 1.01? Yeah. Heck, what about 1.000000001? What about 1.00000000001? So how do we shade in everything to the right of 1, not just the 2 and the 3 and the 4, but we're not allowed to shade in to include the 1. Well, here's what we do. I bet you already know. Here's how we, represent this graph. You put a circle on the 1, but you leave it empty to pretty much tell the whole world that we're not including this number, the 1. But literally everything to the right of this number, including 1.0000001 and stuff like that. And so we're going to shade everything to the right of this number, but we're not going to color in this circle because 1 does not count as an answer in our graph of, x, everything greater than 1. All these numbers. Now, contrast that with the symbol. We want to graph all x's that are less than or equal to 2. So now, if we're going to shade in everything that's less than or equal to 2, now we're going to not only put a circle on the 2, but color it in. Because now 2 is included as a solution because we could also be equal to 2. And we also want to shade in everything that's less than 2 as well as equal to 2. So that means we're going to shade to the left. Okay? And that's that graph. And you got to put in, just like in the first example, you got to put an arrow here because this graph theoretically goes forever in this direction. Everything that is less than or equal to 2. Now, someone in class always points out that, here's a good rule of thumb. You see how this symbol is it's almost like an arrow that's pointing left? That means you shade to the left. And I always say, heck yeah, you are correct, ma'am, or you are correct, sir. But what you have to make sure you remember about this rule of thumb is the variable, the x or the m or the p or the whatever, needs to be on the left. Okay? And so in this next example, I'm going to jump ahead to example 5. I'm going to jump ahead to example 5. I don't care what you say. So in this example, not only because people like that rule of thumb sometimes, but I usually have people rewrite these things for a lot of reasons so that the x comes first. So now, long story short, if you write 2 is less than 5, well, maybe I should put the greater than first. Yeah. So if I write 5 is greater than 2, if I want to read this statement but instead have the 2 be spoken first. Like, in other words, if I want to read this statement from right to left, I can't have a greater than. I have to say 2 is less than 5. And yeah, that's pretty much how it has to work. If you read this from left to right, it says 5 is greater than 2. But if you read it from right to left, it pretty much says 2 is less than 5. And so anyway, yeah, it's probably better, arguably, but I mean, my strong opinion, to always have the variable be spoken first on the left side. So I'm going to rewrite this statement. Negative 2 is greater than x. I'm going to rewrite it as x is less than negative 2. And now that is much easier, in my opinion, to wrap your brain around when it comes to doing the graph of this. And you're going to put an open circle on negative 2 and shade to the left, because that's where everything is that is less than negative 2. Going back to number 3, you might recognize something like this. I don't think it'll take too much convincing from me that this is 2 inequality statements, 2 inequalities at the same time. And you could break this up into its 2 separate, look at this. This inequality is saying that x is greater than or equal to negative 3. In other words, I don't want to confuse anybody. In other words, negative 3 is less than or equal to x, which I like to say the x first and say x is greater than or equal to negative 3. But this is also saying that x is less than 2, at the same time. It's 2 inequalities at the same time. And if you think about this together, okay, so what's greater than or equal to negative 3, but also less than 2 at the same time? Isn't this just going to be all the numbers in between? In between negative 3 and 2. And according to these symbols, or equal to and not or equal to, we're going to include the negative 3, but we're not going to include the 2. So I'm going to put a circle on 2, a circle on negative 3, and this guy's going to get colored in, but not the 2. And look, I know I just got done saying, and it's not like I was wrong or anything, but that we're going to basically shade in between these 2 circles. But technically, don't forget that this is technically 2 different graphs that combine together to make one combined graph. So greater than negative 3, greater than or equal to negative 3 technically, but also less than 2, 2 separate graphs that basically make one final graph together. They collide and they make one graph. And I'll probably elaborate later about this, but because of the word and, these combine together. But bottom line, at the end of the day, you should see this type of deal as, everything in between negative 3 and 2, including 3, not including 2. And so this one, it's the same thing. We're going to basically, at the end of the day, be graphing everything in between negative 1 and positive 1. But here it looks like, because of the or equal to business, we're going to be coloring in both circles. And so everything in between. And side note, you might have different styles of like graphing this stuff on number lines. Maybe a little squiggly or curl, I don't know, little curly line, or maybe you even go up above the number line to draw this thing. Like maybe you do this kind of deal and put them up there. But I don't know. I feel like I need to tell you that, let's say like on the Keystone exam, at least as far as I know, you're going to see the graph like on the number line. Okay, one final piece of business here. Translating phrases and sentences and paragraphs and word problems to inequality statements. Okay, so write an inequality to describe each statement. And by the way, it's going to involve using a variable to represent, the thing that can vary. So here we go. Number one. All temperatures in the universe. This got real interesting real fast. All temperatures in the universe are above absolute zero, which is negative 273 degrees Celsius. So we're going to use the variable T to represent all these varying temperatures. And so how can we write an inequality that says that all temperatures are above this number? Wouldn't it be this? And do you see how we would use the symbol, the inequality of greater than, strictly greater than, and not greater than or equal to? Because we are above this. We're not above this or equal to it. We're strictly above it. So here we go. Number two. Altitudes in the Death Valley area range from 282 feet below sea level to about 11,000 feet above sea level. So basically this below and above business just pretty much means that this is going to be like a negative 282 and a positive 11,000. Ooh, so we are, okay, if I'm reading this correctly, and I believe that I am, this is saying that all these altitudes are going to be between negative 282 feet and positive 11,000 feet. So isn't that going to be the whole thing where it's like, isn't it going to be this type of deal? This whole like in-between business? And so the inequality is going to look just like this, but with the correct numbers. So the only remaining question I have is this verbiage giving you the vibe that we're between negative 282 and positive 11,000, but could we also equal? Are we in between and including negative 282 and including positive 11,000? So basically, what I'm getting at here is it going to be like less than or equal to symbols that we use? And like if the verbiages were ranging from this to that, I think we can go ahead and use these symbols, less than or equal to A, which is less than or equal to 11,000. Okay? I mean, the verbiage, it's very intricate, and you got to be very careful about how the verbiage is describing the numbers and the situation. Number 3. Water can be in a liquid form between this temperature and this temperature. So we're going to use the T variable again. But again, it's like we are between this degree and this degree. Are we going to use the less than symbols or less than or equal to? You think like the verbiage here pretty much says that we could also Like water could be in a liquid form at exactly 32 degrees and 212. Can we include those? And I mean, this specific example with water, and how like this is freezing and this is boiling, but I think like the whole just simple verbiage of between means like between and not including those endpoints. So the symbols here are just going to be less than, because I don't think T can also equal 32 degrees Fahrenheit or 212 degrees Fahrenheit. It's got to be strictly in between. And it is pretty vague in my opinion, but maybe if they would have used the word strictly between, the word strictly, that would have made it a little more clearer, at least to me. But so watch yourself around like different verbiage. Now, I'll throw in a couple bonus examples, I guess, just kind of like verbally here. Other very common examples are like, hey, you have to be at least 18 years of age to buy tobacco in this country. You know what I mean? So the key words there are at least. You have to be at least 18 years of age. So your age has to be at least 18. Is it this symbol, or do I need to include the or equal to? At least 18 years old means like you could be equal to 18 or older. Let's see. Your teacher is going to give you at most 5 questions on the next test. At most. So, what did I say? Questions? At most 5 questions. So, the questions is going to be less than or equal to 5. So that's what the words at most implies. It's going to be less than or equal to 5. And I feel like I'm forgetting at least one pretty common one, but I'm going to stop there and just, you have to learn, especially with the keystones being in your eventual future probably, phrases like at least, at most, in between, right? You got to know how those things translate to inequality symbols and stuff like that. And so that is section 6.1. Yeah. Thank you very much.